So you have better things to do with your life. But if you want to go home and see what it looks like tonight, I'll have that also listed under tonight's homework. I'll put this video and the homework for tonight. But just to go through these numbers, natural numbers, I feel like we don't use natural numbers after like whatever grade we learned 0 in. But when we're little and we learn to count, we don't start with 0. Like when I teach my kids to count, we start with 1. So those are called the natural numbers. No fractions, no decimals, no negatives. Whole numbers is kind of what we deal with in elementary school. Whole numbers start with 0. The only difference between natural numbers and whole numbers is that 0's in there. And then somewhere along the way, for me it was 7th grade, but I feel like you guys learned negative numbers way before then now, is we say, oh yeah, we forgot to tell you that you can subtract 7 minus 9, and there's a set of negative numbers. Integers, I feel like, is where algebra starts. We don't really tend to say much, we don't use whole numbers as much anymore except for story problems. But notice that integers still have no fractions, still have no decimals. So if they ever tell you to give only integer solutions, then you wouldn't give fractions or decimals. Rational numbers, when I teach Algebra 2, I tell the rational number is a number that can be written as a ratio. But I thought I'd give you some math lingo here for the definition of a rational number. So I threw in this set builder notation in that this little symbol, a line or a colon in between there, is called set builder notation. And we would say the rational numbers are any number that can be written as a over b, which means a fraction, such that a and b are integers and b can't be 0. It's just a really fancy way of saying it's any number that can be written as a fraction. Can't have 0 in the bottom, so that's why they have to put that in there. And that these are integers, which means it's not a fraction over fraction, which, yes, you could simplify. But that's all that's saying. Set builder notation, math lingo, ways they can write definitions without writing as many words, because we're going to learn that math people don't like to write words so much, so they use a lot of symbols so that they can shorten it. If we ever use set builder notation and you don't know what it means, you can always write it out by hand in your notes so that you'll have it. But this will come up a lot. Rational numbers, any fraction that's terminating, any decimal that's terminating or repeating, because you can write those as fractions, right? Think of 2/3, it's a repeating decimal, but you can write it as a fraction. Anything that's not a terminating or repeating decimal is an irrational number. And I always love the definition for an irrational number is a number that is not rational. It's irrational. So you have to know what a rational number is in order to know what an irrational number is. So pi, square root of 3, anything like that is an irrational number. Questions about that? All that together makes the real number set. In Algebra 2 last year, you learned that there's also non-real numbers, the complex numbers with I. We'll talk about that as well. But this is our real number set. And we can I have a slide on here with the Venn diagram, but I worry showing you because I don't want you to feel like you have to draw it. But it just kind of shows you that all these numbers kind of set in each other. So I'm going to show you this next slide, but don't feel like you have to draw this. It's actually from the Algebra 2 book. And there's these letters that everyone in the math world know that they use for numbers like natural numbers, whole numbers. Integers are always called z. You can't call them I because that's irrational. Rational numbers are Q, and R is real numbers. I remember when I taught Algebra 2, I think this is the same first section that you do in Algebra 2. It says, like, name the number set, and if you look in the back of the book, it says, like, Q, Z, and everyone always thought they had to memorize those letters. You don't have to. I mean, you can, but you don't have to know that Z stands for integers. But just to kind of show you that they're all subsets of each other, except for irrationals. Irrationals are totally separate. Questions about that? Interval notation. I don't know how much you did this last year in Algebra 2. I know that you at least did one section, but it's very early on. So interval notation is something that's used a lot in college math classes. If you don't get a dual credit before you leave high school, there's a good chance that you're going to be taking a math class in college, no matter what your major, because every major requires some algebra class. And those algebra classes tend to use interval notation. I like interval notation better than that set notation with the brackets. The Algebra 2 book uses that a lot, but like when we do domain, And range, I like the parentheses and the brackets. Do you remember doing that last year? Like negative infinity to infinity. So I just want to review those rules with you in case you forget them. And a lot of your homework today is doing the interval notation. So hopefully if you remember that, it will be really simple. They do talk about the vocabulary here. A bounded interval means one that has a number at each end, and we'll talk about in a minute what it looks like when it doesn't have a number. So bounded means it has a number at each end. And I just use A and B, but those could be any numbers. And then, so if I said X is in between A and B, including A and B, that means that it could be A and B. And the way that we show that is we do a bracket, right? So that would be the same as saying bracket A, comma, bracket B. That means everything between A and B, including A and B. So that's another word there. Closed means that the endpoints are included. As opposed to the exact same thing, except for the endpoints are not included. That's called open, and to show that, instead of using a bracket, we use a parenthesis, So when I write domain and range, this is how I write it. The domain is from bracket 3 to infinity. Set notation is okay, but I really want you to be aware of interval notation because it's used in this book. It's used in calculus if you're going to take calculus. So I'm just going to kind of go through these, and if you remember this, you might not need to write all this down, but I'm just going to go through all the options that could happen when we write intervals. Like, it could be half open, or if you're a glass half empty kind of person, you could call that half closed, because it kind of means the same thing. But it just means one end is included and one end isn't, so I gave both options here. This one, A is included, so we would say bracket A, B is not included, I would say parentheses. And the other one's the other way around. Starts with A, but A is not included. B is included. And so you just have to be careful with your brackets and parentheses. Memories of this? And then we have unbounded intervals. Unbounded means that at least one side is going on forever. And when we talk about domain and range, that happens a lot. Very rarely do we have a domain or range that's just from like 3 to 7. Right, like it goes on to infinity. So unbounded just means that I'm just going to put includes infinity. The more I write, the worse my infinity signs look. So please don't take offense. I will tell you that last year I learned in pre-calculus that Mr. McClure makes his infinity signs, or teaches you to make his infinity signs with like just 2 circles. And I just like to point out that you can make a very nice infinity sign if you just like an 8, only it's just on its side. So you can all practice tonight making fancy infinity signs instead of just not open. I'm not going to mark that wrong. But I was offended last year. Mr. McClure was like, I only do that because they struggle making the signs like that. And I was like, come on, McClure. But when I taught Algebra 2, I would have some kids that always turn their paper sideways, and then they would draw just an 8, because then when you turn your paper back, then it's the same. Don't do that. That's way too much work. But you can practice. And as you doodle today in your other classes, when you're just thinking about math, because I know that's what you think about when you're in English, you can just practice. Oh, how nice that I can make infinity signs. We'll use infinity a lot. So, unbounded could be unbounded and closed, and unbounded and open. And again, open and closed just means whether it's included or not included. So if this is everything greater than or equal to A, that means we're going to start at A, but it's going to go on forever. So, let's see, look, that's a bad infinity sign, but that's okay. And it's going to go on to infinity. Infinity is always a parenthesis, and if you think about it, you can never reach infinity, so you can never put a bracket around infinity because it's never included, right? Like, no matter the biggest number you can ever think of, you can always just add 1 to it, and it's bigger. So you never put a bracket around infinity signs. And so same thing, again, you might not want to write both of these down because you get the idea. But if it didn't include A and it was everything bigger than A, it's just from A to infinity. We're almost done with this part. Some people always have a really good memory of this, and then some people look at me like they never learned this. So I try to make sure I hit it hard on the first day. If we're going less than, remember that your notation here, it's the smallest number to the biggest number. So remember that if you're going less than, then your negative infinity is going to come first. So if it's everything less than or equal to b, then it's going to reach b and be less than that. So it's going to be negative infinity up to b included, or negative infinity up to b parentheses. I got this new email, and every time I get an email, I get that little ding. I need to learn how to turn that little ding off. Maybe. Genius. And last one, I know if you remember this, you remember this one. All real numbers, that means if the domain is everything, then how do we write that? Suddenly just there. Negative infinity. Parentheses. Okay? So part of your homework today, they're going to give you an inequality, and they're going to ask you to write it like this. They're going to give you this and ask you to write it like this. And they want you to use those words open, closed, bounded, unbounded. So we'll do that in our homework today. I'm not going to stress that much on the test. I'm not going to say, is this bounded or unbounded? But it's not a bad idea to just practice it in your homework so that you know the lingo when they're talking about it. So we'll practice a couple of these. Some of these are writing, and so I don't know that you need to write all these out. Time to be out of here, 10:06. So we'll just do one of each one of these. It says, describe and graph the interval. When was the last time you made a number on McDonald's? Describe. They don't want you to say x is less than or equal to 2 and write that on words. That's not what they mean. They mean use those words, bounded, unbounded, open, closed. That's all you have to say for describe the interval. If it helps to do it in interval notation first, to look at the brackets or the parentheses, that's okay too. But that's what it means by describe. It says graph the interval, which means I guess they don't even want you to write it in interval notation, but I'm going to. If x is less than or equal to 2, I know that means that's going to be negative infinity up to 2. So if infinity is in your notation, is that bounded or unbounded? Unbounded. And if there's a bracket, that means open or closed. Half open, half closed, half open. I think because it's unbounded, yeah, if we go back to this, if there's 2 endpoints, yeah, that's kind of weird. I think I'll count it right if you say half closed on that, because it is only half of it. But on the ones with infinity, the book just says because one side's infinity, it's unbounded. Infinity's not really a number, it's an idea. They don't actually use the half on there. But I get where you're saying if you say half on it, so we'll say okay or not okay. So I just want you to graph that. I will tell you when you look these up in the back of the book, when you graph these, remember back in, I don't know, when's the last time you made number line? I don't think in Algebra 2 you make number lines very often. But you always put like a circle or a open circle, right? Like if it was included, you put a filled in circle, and if it wasn't included, you put an open circle. Well, the advanced way of doing this is instead of putting an open circle or a closed circle, you put a parenthesis or a bracket. So on these, like if you look this up in the back of the book, this is in the book. I don't care how many numbers you do this. I don't know how other teachers have done this. And when I do this, I usually do this. Oh, I'm going to put 2 right there because that's the number I need, and I don't put anything else. Maybe that's because I'm lazy. But I don't care how many numbers you put there as long as 2's on there. If it's less than or equal to 2, I know that that means 2's included. So to do that, we put a bracket on our number line. Smart board is dying on me. And notice I put the bracket the same way it is in the notation, and less than means it's going to be going to the left. So that's kind of a new thing. In the past, you've used circles, and now you're going to use brackets or parentheses. If you're checking your answers in the back, which is why they're back there, not to copy, but to check, and you forget, and you look back at your answers, it'll help you remember to go back and put a bracket or a parenthesis. What about this one? Is it bounded or unbounded? Bounded, is it open or closed, or half? Closed completely. So we can just say bounded and closed. And again, when I graph this from -3 to 3, again, I want to make number lines. It's really nice because you just copy down the interval if it's interval notation. So I can just say, oh, bracket to bracket, and by looking at that number line, I can tell from the number line that it's everything from -3 to 3, including -3 and 3. Questions about that? Exciting first day. All right, let's look at the next one, decide if we want to write this down. All right. Like, what about this? You don't have to write this one down because it's kind of a silly amount of writing, or maybe you could just write Bill is at least 29 years old if you want to write that. But there's some on your homework that give you a situation, and they ask you to use interval notation and inequalities to do this. It's just basically looking at the at least, at most. I think it's okay to do, but you tell me. If Bill is at least 29 years old, what does that mean about Bill? He's 29 or older, or 29 or younger? 29 or older. How would we write that in an inequality? I'm going to use B for Bill, but you can use whatever you want. You don't have to write it down even. Bill is less than or greater than, or what? Greater than or equal to 29. And you can use X if you want. So, using inequalities, I got that. Using interval notation, who can put Bill is at least 29 years old in interval notation? Any takers? So, 29 is 29 going to have a bracket or a parenthesis around it? Definitely bracket. Is 29 going to be the first number or the second number in my interval? Because he is 29 or older. So first, and I feel like we could argue the point here that Bill cannot go to infinity. We probably could be able to put like 113 as long as anyone lives. So you could argue the point that it shouldn't be infinity. But mathematically speaking, we're going to say greater than or equal to, we're going to say Bill can be infinity years old. That's ridiculous. But you could say 113 and I'd go with you. Yeah? I should check with Mr. Allspaw today and see if he's going to teach infinity sign. Okay. And we would say that that is unbounded and closed, or half, if you want to say. This is on page 8 in your book, if you don't want to write all these down. But I feel like the exponent rules, every year in even calculus, I have kids that forget when do I add exponents, when do I multiply exponents. Page 8 in your book has the set of rules of what they are. So if you don't want to write all these down, you want to look at page 8, you can. I just want to remind you of this, and I'm going to give you a few problems. We might do one together if we have enough time. But I'm going to give you some, and we'll talk about them tomorrow and see what you remember. But sometimes people get thrown off because there's so many letters in this, but they're just the bases and the powers. So if you have the same base, and you're multiplying the same base, what do we do with the exponents? You remember? You add them. So u to the m times u to the n is u to the m plus n. Right? And again, if you remember this, you don't have to write them all down. I just wanted to remind you, because people forget. And when we divide exponents, remember you can cross stuff out. So the shortcut there is we subtract them. And anything to the 0 power is 1. Last year in my ECA lab, we had been practicing for the ECA test, and we got to a question, we were doing the clickers, and I was like, it was a big question to the 0 power, and they all checked their answers, and I was like, anything to the 0 power is, and everyone in the class was like, 0! Like, they were so excited, and it's so depressing. I just laid on the floor. It was a defeating moment in life, but that's okay. Negative exponents, we'll talk about those more, but remember, it just means they're reciprocal, so my little method is you move it to the bottom of the fraction, so that means it goes to the bottom and it turns in its negative sign. So a negative just means the reciprocal. It's in the bottom and it's negative, you move it up. And then these three kind of just, I don't know, I always say it's kind of like you distribute the exponent to everything, but it's not really the distributive property. But if you have a product or a quotient to a power, you have to give that power to everything. So if you see parentheses, the first thing you want to do is give that exponent to everything. So that would be u to the m, b to the m, and I'm going to jump to this one, same thing with division. That would be u to the m, b to the n. Does not work with addition or subtraction because x plus y to the second, you can't just give that to both of them, right? You have to FOIL it out. And a power to a power, right? One base, two exponents, we multiply those. Right? It's a lot of rules. People get them confused, but we will be simplifying them as we go along there. Okay, so maybe let me just take a real good example here because I have like 3 of them, but I don't want to. We're not going to get through 3 of them. Everybody have that? If I ever go too fast, just let me know and I can switch back to the slide. But I don't know if you don't tell me. Okay. And the great thing about them being online is if you miss something and you don't tell me and we don't go back, you can always go online and get them because they'll be there. Okay. Let's see if we can find a good one here. Oh, do you want to do one of these or you want to do this one? Start ugly or start easy? Ugly. There's a saying in my class from my students that I always build you up with easy examples just to break you down with a terrible example. But it's not true. That's just math. Like, math builds on itself. You don't want to start with awful, but we are today. If you see parentheses and you have exponents in a problem, you want to get rid of those first. And so the first thing that I'm going to do on this one, I don't really know what number this is now. 3, 4. I messed up your number. You want to get rid of that first. And so you want to know that if you have a power outside, you have to give it to everything on the inside, and a power to a power we multiply. So I'm going to show a lot of work here. I used to teach Algebra 1, so I'm good at showing work. If you don't show all the work, that's okay too. But I'm going to give this to each one of those. So x to the negative 3 to the negative 4, I'm going to multiply, and that's going to be x to the 12. And 2, y squared to the negative 4, 2 times negative 4 is y to the negative 8. You can't really, I mean, I guess you can move stuff around when it's negative, but I like to get rid of parentheses first. And the same thing on the bottom. 6 times negative 2, they're both exponents, so that's y to the negative 12. And negative 4 times negative 2 is x to the 8. Good or bad thing about this, depending on how you look at it, is there's lots of ways you can do this problem. Even you didn't even have to do this first step first. But if you are okay with subtracting with negatives, you could simplify from here. The x's, top minus bottom, and you can get your answer. If you're not a big fan of having the negatives everywhere, anything with a negative exponent, you could switch places, and then you have all positive numbers, and you don't have to worry about messing up negatives. If you have a calculator, it's not so bad to do this. So I'm going to do this both ways just to show you. If you just want to get to the answer from here, we would say these, right, they're the same base, and when we divide, we subtract. 12 minus 8, I can even write it out here if you want, x to the 12 minus 8 would give me x to the 20. And since my y's have the same base, even though they're negative, that's okay. I can subtract negatives. I would say that's y to the negative 8 minus negative 12, which I tend to just make positive sign. Negative 8 plus 12 would be y to the 4th also. How do I know I'm done? I've simplified everything that can be simplified, so there's no negative exponents. That's how I know that's my answer. Not out of time, so I'm going to stop on the other way. But look in your book for their examples to see how they do. Okay, so here I want to give you some homework, because I don't want you to be sad this weekend when you have no math to do. Write this down before you leave. I will put this on Harmony, so if you want to go back and look at it, or if you don't want to write it down now, I will attach this with the video on Harmony. But we will start, go over questions on this on Monday, and we'll do the next lesson.
Okay. Campus, please. I need Trey Blades and Addison Blades, Olivia Arnold, Taylor Schroeder.